What are the two kinds of complexity in software? I'm Chris Thanis. I'm a KMP developer. Tech support said they're coming out for that for sure. They're going to close it up finally. Jesus. All right. I'm going to be watching, reacting to this Venkat Subraham, which I really like. I like his presentations. He definitely knows his stuff. He's definitely been down in the pits, and I appreciate most of his insights. So let's get into it.
What do we do in our daily lives? What we do mostly is we deal with complexity. And there are two kinds of complexities we have to deal with. One is inherent complexity, and the other is accidental complexity.
Yeah.
Inherent complexity
When I first heard this phrase, I was like, "What are you guys talking about?" But now I fully understand what they're talking about.
is the complexity from the problem domain. There is nothing you can do about it. When you're dealing with
we got the problem domain, which is the inherent complexity, which this is the problem we are tasked to fix up and make easier somehow, make better. And yeah, these are all the standards, some of the standard stuff you're going to need to do for CRUD application or storing information in a more efficient way than a spreadsheet or in paper instead of filing cabinet.
the problem, there are complexities of the problem you have to deal with. And this is the nature of the application nature.
Right, and there's the text, then there's all the tech tools, all this tech tool stuff that we're going to apply, API support, HTTP socket, MT, all that stuff. That's the accidental. It's all because there's always a better way of doing it, right? So there's some bit of complexity we're just never going to get rid of. And then the problem in the solution space, so the problem space and then the solution space, we're going to have problems dealing with whatever tool we bring in, whether it's a screwdriver, whether it's a hammer, whether it's a skill saw, a bow saw. They're all going to have issues that we have to deal with. Let's keep going.
Of the domain, and you have to deal with it. But fortunately or unfortunately, most of what we deal with on our daily basis is not that inherent complexity that we deal with as much.
Sometimes it bleeds through, but let's keep going.
We deal with is the accidental complexity.
Yeah, this technical stuff. It's been a real pain in the dick. It's been a real pain in the neck to deal with this stuff because it's just a lot of it's half thought out through. Like these things are also run on. They don't have unlimited time and budget to get these things ironed out completely. The Android operating system has been a really great example of that. Holy man, they're just like, well, it works now. Like for what we tried to do for this. Like, can you do this with it? Can you do that with it? Well, I guess we could change it around, revamp the whole thing, whole start from scratch, push that to side, the whole thing. Don't ever mention it again. It was just like, we were dumb then. We're so much smarter now. Let's keep going.
Dental complexity often comes from the solution that we use to solve a particular problem. Ooh. The solution we are using brings certain complexities.
Ooh, you got 1, 2, 3, 4 layers of loops. Woo! This might take a minute. Might take a minute
into the table. And what do we do from there? To solve that complexity, we bring other solutions. Those solutions bring more complexity, and we get dragged into this vicious cycle very quickly, and becomes really, really hard.
Right, and then we add personalities of the people involved, and there's these super fast startup cycles, and then dump cycles where people, we lost our funding. We only had 3 rounds of funding, so we can only last 22 months anyway. So it was like getting hired, then they're getting fired, like all that stuff. Everybody's so they got to pad their resumes, and they're not going to get the right kind of raises. They got to jump to another company. And then we got this massive turmoil because people are padding their resumes and they're jumping around from company to company. People coming in trying to figure out what the heck's going on. It's like, just get it done this sprint. We just got to get it done this sprint. And wonder why the software becomes unmaintainable or totally misunderstandable. And everyone's building fiefdoms of these little companies trying to survive. Let's keep going.
If you want some examples of accidental complexity, there is one we all can immediately share and think about, which is concurrency. Now think of concurrency for a minute. The application may or may not need concurrency, but the minute you bring concurrency, what do? You start threads. Oh, great, I've got threads.
I mean, that's one way. Yeah, Kotlin doesn't use that stuff. I mean, it's there. You can use it if you really want to, but it does it a whole different way. Let's keep going.
I want to make sure that threads do not collide with each other and start corrupting data. I got to make sure there's no race condition in code. You start putting constructs around.
Woo! I was like, is there any way if there's like, you might as well just say bottleneck. Let's just say bottleneck right here.
Like locks and synchronization. And now what happens? The code is doing a lot of stuff to keep the concurrency in place, and put with all that code in place,
this is part of that solution, right? That particular solution has all these other things around. It's like, oh, we could do a bunch of stuff in parallel, but then coordinating it, and if things fail, how do you keep them start over? Does everything fail? Like all that structure stuff is like, that's where Colin came in. It's like, we gotta have some structured concurrency here. Let's keep going.
Every time we walk in to change the code, it becomes a lot more expensive to change the code as well. But where did that come from? That's an accidental complexity.
Yeah.
The problem did not require this.
Well, we didn't think it through all the things we were going to do. It was thought out through that one next thing, and not the next thing after that. They were only, the whole computer industry has been done that way. We haven't had the computer revolution yet. The software revolution hasn't started yet. This is still 1970s technology. Let's keep going.
Particular solution, it's a solution we chose to solve the problem. And if we step back and say, hey, maybe I should really think of a different solution rather than this particular problem, maybe that's a better solution. And it doesn't have these consequences of locks and synchronization. Maybe that's a better way to handle this problem.
Colin,
one question to ask.
They have another answer to that, but which I think Venkat knows. He knows about it, so let's keep going.
The other question to ask is, how many times do we really ask the question, what problem am I really trying to solve?
Well, yeah, I mean, but that's not really asked of us, is it, right? Most of it is like, you got to get your ticket done. You got to go and like and subscribe over there. I'll put the link in the deal. Yeah, we're not really giving, that's not what a lot of these companies are asking of us, right? It was like, here's a ticket. How many points you think you're going to be? It's not asking how does this work in this context.